Welcome to our session 4 lab video. So let's jump right into it. So we have 3 models that we need to do basically. We've got 2-4, 2-8, and 2-10. So if you go to where it says session 4 homework assignment instructions, if you click on that, you'll find the PDFs and the instructions on what you need to do. But this basically, for this first session, our first real session of constraining parts and modeling them, our goal basically is to model the 3 parts and then make sure that all our sketches are fully constrained. Now again, remember in the olden days, or really the previous versions of the software, the goal was to change it from green to purple. So you may see instances of that mentioned in my instructions in places. I'm going to try and catch them all and fix them. But the new color change now, since Autodesk has decided to change the colors, we're trying to switch our sketches from purple to black. That means they're fully constrained. So if you see colors being mentioned all over the place and they don't match, or I missed fixing them, your goal is for your sketches to be fully constrained, and that's what we're going to try and do when we go through this together. Okay, so I'm going to go ahead and download all 3 of these PDFs. We're just going to do these all together in the same video. And you'll want to open them up so we can refer to them. Sometimes it's helpful to print them out, but I'm just going to pull them up in PDF form here so you guys can see them. Okay, so here's our first one. This one's called gasket. This is 2-4, and this one's in metric. You can see it says millimeters down here, so we're going to do a metric eye part. And then we've got a thickness of 2 millimeters that we're going to extrude this to. So you can see this is sort of like this notched out square gasket shape around the edges. That's what we're trying to make. Okay, so I'm going to go ahead and jump into Inventor. We're going to start going a little bit quicker now and try to get more of just a standard process as we go through this and start to, kind of string these commands together. So we're going to go New, Metric, Standard Part File. I'm going to jump right into a sketch. That's pretty much what I always do. Keyboard shortcut is S if you don't want to have to come up here and hit the button. I'm going to go on the XY plane. And my next step at this point, you've probably figured out, is always projecting my geometry, because that gives me some capabilities with some of my geometric constraints that I don't have if I don't have those projected in. Okay, so for this, what I'm going to do is I'm going to grab my rectangle tool, draw out a big rectangle here. Okay, kind of get everything set up. And now I'm going to go ahead and just draw this notch shape on the inside with the line tool. So you can see I've got kind of 4 voids here and then 3 tabs that stick down, and I'm going to do that on both sides. So I'm just going to grab the line tool. Don't worry about making it perfect. We're going to fix it all with our geometric constraints and then subsequently some dimensions once we sketch it. So don't worry about making all the lines the perfect size. You don't even have to worry about typing in dimensions here. I kind of advise people to not do that. This box pops up in Inventor where it asks you what size you want things to be. This isn't the step for that. I really wish they would take that out, because to me it kind of sets people up for bad modeling practices. That you really want to do the dimensions towards the end, at least in my opinion. Okay. Now notice I'm also doing something when I draw this called inferring a constraint. When I draw this, you may not have noticed this before, but it's important to kind of read between the lines in Inventor when you're drawing stuff. So as I draw this line, yeah, you don't have to worry about getting the perfect size, but you can program in some of the shape of your part as you model this. So notice when I'm drawing this, if I come down to where I want this to be horizontal, it will snap in. And you can see I get an icon between these 2 lines that pops up for a perpendicular constraint. So what that's showing me is if I draw this line right here, Inventor is going to make it whatever length I have, but then it's going to also automatically put that perpendicular constraint between these 2 lines, which is going to save me the step of having to come up here and pick it and choose the 2 lines. Okay, so paying attention to these icons that are popping up while you draw can be helpful. I do want these to be perpendicular. Okay, so I'm going to go ahead and draw through. You can see right here it's locking onto these other lines over here. That's great. That's what I want. I'm also getting another perpendicular constraint popping up down here. So I'm going to go ahead and just try to kind of match up to this stuff. So keeping it horizontal and vertical, coming down, boom, right there it locks in. I'm going to draw that, come over. I'm not going to click on this. This is something that would be a rookie mistake in my opinion. So if I click right here, you have to think about what's going to happen if I accidentally click on this yellow line. And if you look at the icons that are popping up, you can see that it's going to go ahead and make a coincident constraint. And what that means, I'm never going to be able to separate that point from that vertical line. So you have to be very understanding of clicking on specific things when you draw this stuff out. From a geometric constraint standpoint, what's going to happen. Okay, so when you're drawing, you really should be thinking about that, not sizes. And that's one of the reasons I really wish that they would take this number box off of here where you're supposed to type in a dimension. I think it distracts people from the important part of what's really going on. You have to pay attention to what you're clicking on, not the sizes as you're drawing. Okay, so ignore the box with the numbers. It's all about what are you clicking on and what's the relationship between that and everything else that you've drawn geometrically, or what's the shape of it. Okay, so I am not going to click on this yellow line because I don't want this end point to sit on that line. It's going to end up over here somewhere. So I'm going to stay away from that. I'm just going to come over here, go up, click again. So again, I'm making these things horizontal and vertical if I can, and again, lining them up if I can. So I'll draw the last tab in here if I come down, over, up, over, and there we go. Okay, now I'm going to show you another trick for this also. We could go down and draw everything down here again, but that's wasted time. So what I'm going to do is grab my line tool. I'm going to put these two vertical lines that go straight down to the midpoint. So I'm going to click here, go straight down until I lock in, so you'll see it snap right there. And you can see my icon changes to a coincident constraint. It's going to lock my end point to be in line with this x-axis. So I'm going to come straight down till it snaps right there. I'm going to click, and I'm going to do the same thing over here. Straight down right there till it clicks. Okay, so that's half my drawing. So what I'm going to do now is I'm going to go ahead and select all this. And I'm just clicking and dragging here. The other thing you can do is hold down Control on your keyboard and go through and manually click everything. So that works too. If you hold down the Control key, you can choose more than one thing at a time. You can also drag select it with the mouse. So I'm going to go to the mirror command. And I'm going to choose my mirror line and click this axis. And then hit apply. Okay. Now a lot of people would look at this and say, oh, it's messed up. I'm not going to do that. Let's do a Control Z. Don't worry if it's overlapping your rectangle because we can very easily fix that, right? So a lot of people ask also at that step, well, why did you use the mirror command and not a symmetric constraint? So they're two different things. The mirror command is made for creating new geometry, like adding more lines or circles. So since nothing down here has been drawn, I need to actually create that geometry, and that's going to be the mirror command. If I had something drawn down here already and I wanted it to match something that's already drawn on the top, that's going to be a constraint. So a constraint is used for existing geometry. The mirror command would be used to create new geometry that doesn't exist yet. Okay, so while the mirror command and the symmetric constraint are very similar, they have two different purposes. Okay, one creates new geometry, the other one constrains existing geometry. So that's why we did the mirror command. Now we've got that in there. So with that being said, if I click on some of this stuff, you can see that when you use the mirror command, it also automatically creates a symmetric constraint between those objects when you mirror them. So if I move this, you can see the one on the bottom follows it. If I move this, the ones on the bottom follow it. And you can also see all my lines are matched up because when I drew them, I made sure that they snapped onto each other. Now, if you get an instance where that doesn't happen, like let's say, trying to find an example here. Let me just delete one of these out. Let's delete these lines. You may have something like this happen if you miss one of the clicks while you're drawing. And let's delete this out maybe. So I'm going to break this on purpose. Don't do this part. This is just to show you how to fix something in case this happens to you. So let's say your drawing looks like this and you can't get it to match up, right? What do? A couple choices. You could use the equals constraint. So I could say using the equals constraint, I'm going to make these two lines equal in length, or maybe these two. That could fix it, right? Because if the lines are equal, that means the other ones match up. The other thing you could do is use a collinear constraint. I could say if I use my collinear constraint, that takes the lines and makes them lie in line with each other. So I could say I want this to line up with this. and I want this to line up with this. That fixes it also. Okay, so if you drew it out and your lines didn't match up nicely like mine, you can still use equal or collinear to go back and match those things up. So I'm going to go back to what I had here. Okay, so we had this. Now something else I need to do is I need to start making this stuff symmetric, because you can see that the left side over here doesn't necessarily match the right side over here. Now remember, we already have symmetry top to bottom, so if I fix the top of this thing, the bottom will adjust itself automatically. So really we're kind of looking at this thing in fourths. I want to fix this part up here so that it's symmetric with this part, and when I fix those top two, the bottom two will follow along automatically because they're already symmetric top to bottom. So what I'm going to do is I'm going to grab my symmetry constraint and I'm going to choose this line and my center axis right here. Those are now symmetric. Okay. Now, Inventor will hang on to that line of symmetry if you want to do additional choices. This is a little tricky starting out, but I think you guys are ready for this at this point with the symmetric tool. So as long as I want to continue to use that line of symmetry, I can choose other objects that have that as a line of symmetry. So for instance, I could pick this line and this one. They're symmetric around that same axis. Now I can go through and say maybe I want this one and 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 this one. Okay. What I can't do is pick lines that are symmetric the other way. So if I choose like this line and this one, no good, because they aren't symmetric around this line. So if you want to switch lines of symmetry, you have to hit escape and go back into the symmetric tool and choose a new axis. So that's one of the things that's a little tricky about the symmetric tool. But once you apply that first symmetric constraint in your sketch, it holds that line of symmetry if you want to make additional selections. It's kind of quick sometimes if you have a bunch of stuff to choose, like on this. Now looking at this, we can also see, as we continue to program the shape of this part in by using these geometric constraints, several of these things are different lengths. Okay? Don't fall into the temptation of fixing this with a dimension. So, if you need to go back and review the lecture video that's in session 4, remember this is one of the most important things we're going to learn this semester, if not the most important. So if you haven't watched the lecture video, I'm begging you, please go back and watch it. It's probably the most important one you'll have all semester. But the dimension tool is not the right thing to do to fix this. So if this is a different size than this, or for instance, this is different than this one, the dimension tool is not the way to fix that. Okay, we don't want to go through and dimension the length of every line in here. That's bad modeling practice, and it's what we call bad design intent. You're setting this model up to behave very poorly and update in a very tedious way. We want to use our geometric constraint tools to change the shape of this object and the way that it changes based on its geometric properties. So I'm going to use the equals constraint here, and I'm going to go through and choose these lines and make sure that they all match in length. So I'm going to say, for instance, this one should be equal in length to this one, and this one should be equal to this one. Okay, now why is it yelling at me? So if you stop and think about this, Inventor is saying adding this constraint will over-constrain the sketch. In other words, you don't need this, or it's already done. So if I stop and think about this for a second, I have symmetry from left to right and from top to bottom. So when I make these two when I make these two equal, this one is already equal to this one because of my symmetry constraint. Okay. There is a button you can use to turn on all of your constraints. Where is it? I believe it's down here. Show all constraints. There we go. This is the F9 key on your keyboard. And you can see why they keep it turned off most of the time. It's a bit much, right? Especially for people that are just starting in Inventor. It's like, oh my gosh, what have I done? But if you hit this is all the stuff that's going on in the background in your sketch that you've put in there already, and you want to kind of try and memorize some of this or remember what's going on, right? So if you hover over these icons, though, it will highlight things so you can see what's happening. So for instance, if I hover over this equals constraint, it shows me, hey, here are the two lines and their equals constraints. Or if I look at symmetry, hey, here is one of the things you did symmetry on. So sometimes it's helpful to see what the constraints are that you're fighting with or that are applied to specific geometry. And you don't want to keep this on while you model, but just to show you, if you go down here and hit this, or you can hit the F9 key on your keyboard, this is what's going on in the background, okay? So remember, we made this symmetric with the one on the other side. So when I make these two equal, every one of these lines is now equal across my whole sketch because the top and bottom are symmetric and the left and right are symmetric, okay? So let's keep going. I want this to be equal to this also because I want all these notches to be equal. So see, when I do that, it fixes all the other ones, okay? I want this to be equal to this. And I think at that point, that might be all of them. You can always, if you're not sure, you can always guess and check. Like if I do this, Inventor will just yell at you and say, that's already constrained, you don't want that. Okay, so it never hurts to check. So now I think we've gotten close to where this is behaving in the middle the way we want it to, except for this one. Okay, so if we look at this, the height or the length of these lines should also match the ones in the other direction. So I'm going to do one more. I'm going to say this equals this. And now they should be square. Okay, and if they change, they all change together. And they're symmetric around the center. And notice, I have not done a single dimension yet. I haven't keyed in any numbers. I haven't used the dimension to set the length on anything. Dimensions are really something you do towards the end. So resist the temptation to throw numbers on everything. It's really not the way you want to go early on. So let's, at this point, see, are we symmetric in all directions? We're not, but we're close. So we have symmetry on everything in this part except for one thing, which is this line and this one. So I'm going to do one more symmetric constraint. So I'm going to say symmetry. This is symmetric to this, and here's my line of symmetry. There we go. So that moves equally. If I click it and drag it, this moves equally. These guys. Okay, so now we're ready for dimensions, and you can see based on all those geometric constraints I did, I can define the rest of this part with 4 numbers. Okay, you don't need like 52 dimensions on this thing to define this part. You only need 4. So if you go back and look, we can actually do this in less than they have on here. They've got a bunch of numbers on here that they maybe don't really need. But, I guess they're needed to explain the part, but not really model it, if that makes sense. So let's put the overall dimensions in. It's 160 by 90. So now we're ready for that dimension tool finally. So I'm going to click this line, 160. Let's zoom out a little bit. My height is 90. Now we can work on the inside. You can see those 2 dimensions define the rectangle. What else? The length of all these lines is going to be 20. So let's put that in first. If I dimension one of these, let's say that guy is supposed to be 20. Okay, here's a point where maybe, Inventor says 1 dimension needed. Well, how do I know what it is? Hit escape a couple times. Anything that's purple or undefined or unconstrained, hit escape a couple times, click it, and drag it around. And then look at what's moving, okay? So what is changing on here? Well, all this stuff is moving, right? So its location is moving, but look at the size of what is moving. Or look at the size of what's changing. It's these lines on the side, right? That as I drag this up and down, yeah, it moves, but in order for that to happen, the lines on the side have to increase or decrease in length to allow that to happen. So really what we need is we need to dimension the length of these lines on the sides, or maybe the distance between these sections in the middle, like from here to here, okay? So if we look here, they've given us a dimension of 70 right here. That would help. So let's dimension from here to here. That's 70. And there we go. We've defined this entire part with 4 numbers because we did good geometric constraining. And now here's kind of the fancy part is if I change this, if I say, well, this is supposed to be 15, it fixes itself, right? And I can say, well, this really is 175. The part fixes itself very quickly and easily, and I don't have to go back and start from scratch and fix all the lines. They don't fold up or explode on themselves. It's a very clean, robust model that I can change with just a few selections, and everything works nicely and cleanly. That's good design intent. Okay, let's do a couple undos. So there's our correct sizes. We'll hit Finish Sketch. Now we can extrude this thing. So choose what you want to extrude. We want these outer sections here. So I'm going to go through. We want that, that, that one and that one. Our distance is 2 millimeters. Now on this one final thing, this is something important to keep in mind going forward. When you extrude this, how do you decide whether you should go forward or backward or symmetric or asymmetric? Okay, I look at the part and I decide, does it have symmetry in the depth? Okay, we know this part is symmetric left to right and top to bottom, but is the front the same as the back? And in this case it is, right? This part is symmetric in all three directions, which makes it kind of unique. So when I extrude this thing, I'm going to try and maintain that symmetry by keeping my sketch plane in the middle and extruding 1 millimeter on one side and 1 millimeter on the other. Okay, and what that does is it means when I sketch this part, my sketch is in the middle of the part and it's symmetric in all three directions around the XYZ origin. Okay, so I'm going to go symmetric, a total of 2 millimeters. So when you put the distance in here, that's your total depth. Hit OK, and we're done. So what that does is if you look at your three sketch planes here, when I did that extrusion, you can see that we're symmetric around this axis and this one. So here's the origin right here in the middle. But it also makes sure if I look at this thing from the side, when I choose that symmetric extrusion option, it makes sure that our third work plane stays right in the middle of the part. So what that means now is the middle of our part is centered perfectly around the XYZ origin in 3D modeling space right here, which becomes very important later on. Okay, it gives you a lot of advantages if you can keep your parts centered up. So that's our first one. Remember to save these things with descriptive names in a folder that makes sense with good file management. So let's go to METC 107 Inventor Models. We're going to make a new folder for session 4. Save this. We'll go into that folder. And this is figure P2-4. Save that. And I'm going to turn these modeling planes off, actually. That's a bad idea to leave those on. So let's save that again. There we go. So that one's done. It's ready to upload. And you can upload that into the Dropbox in Ivy Learn for the first part of our session 4 assignment. Okay, so let's go to the next one now. Close out some windows here. So we finished that one. All right, this one. This one's called a fitter plate. It is in millimeters also. This one is a little unique because it's got symmetry top to bottom, but not left to right. Okay, so this one's symmetric. From looking at the sketch, it's symmetric one way instead of two ways. Other things we've got going on here, we've got a lot of chances to use symmetry. Obviously, we've got a chance to use the equals constraint if we wanted to. We could say this hole is equal to this one, or this fillet is equal to this one. We've got a chance to use the trim tool because we're going to draw a circle here and trim off half of it. Same thing down here. We've got a chance to use collinear if we want. We can make this line collinear with this one. So there's a lot of different ways you could proceed with this one. And again, there's not one right way. There are wrong ways and right ways. Okay, so pick a way that makes sense and follows the rules we've talked about, and you'll be fine. One thing I do like to do though on these parts is I like to leave these as corners when I sketch them and fillet them off in the model menu, or if you're going to do them in the sketch mode, save them till the very end and I'll show you why. But let's go ahead and grab the rectangle tool, and then we're going to fill it in with some of these other features. Okay, so let's close out this model. Let's make a new model. Metric, millimeters again. 2D sketch. Choose that XY plane. Once again, we're going to project in geometry just like we always do. X and Y. So I'm going to start by drawing out a rectangle. And let's go ahead and if we look at this, we're going to have symmetry top to bottom. And well, let's just do this for starting out. Let's use our symmetry tool to center the rectangle. Okay, so I'm going to pick the top and bottom in my x-axis, go back and hit the symmetry tool again because I'm going to switch axes. Pick this line and this one, and then the center line. There we go. Okay, now we can start to fill in some of that detail. So what I'm going to do is I'm going to go and put these notches in here, and then probably this circle here. So let's grab our line tool, I'm going to go over like right around here maybe and just draw that in. Come down to, well, let's use the mirror tool. I could do the same thing down here, but let's just mirror it, okay? Let's grab the mirror tool. I'm going to choose those 3 lines. My mirror line is going to be the x-axis, and hit apply, and done. Okay, so we got that in there. Let's grab our circle tool, and I'm going to go at the intersection of this vertical line and my projected x-axis, my imaginary x-axis. I'm going to hit right there, and you can see it grips onto it with that green dot. I'm just going to draw a circle in there. We'll trim that off in a minute. Then I'll grab my circle tool. Here's one where you want to be careful, okay? You can see if I go up here that it's trying to infer constraints based on some things. So right there, it's trying to lock this circle onto that dotted line, which matches up to the center of this line over here. That's not necessarily what I want. So a lot of times if I'm drawing just off in space over here, I try to avoid those dotted lines. I'm just going to go up here somewhere, draw a circle, and then let's mirror it over. So I'm going to go mirror, choose my circle, mirror line is my x-axis, hit apply, and done. All right, so we've got some stuff in there. We need to do a little bit of cleanup on this now. So let's go through and let's grab the trim tool. And I'm going to trim the outside of this circle off, and then the 2 lines that go through the middle. So here and here. I'm going to trim off these line segments on the top and bottom. That looks pretty good. Now let's go back and check our drawing. If we look at our drawing, this notch is 20 by 20. So to clean things up a little bit, I'm going to use my equals constraint and make this equal to this because I know the height and width are the same. And you can see mine's getting kind of wacky here where it's making these lines not match up anymore. It's doing that because we trimmed the top of this out. So to fix that, you could either do a collinear on the top of this, or I could make this equal to this. That'll fix it too, okay? So a lot of times what you'll see is when you trim lines out of your parts, it allows things to move that couldn't move before. In this case, trimming that line off across the top allows this to move. And same thing over here, you're going to see that this line probably moves independently of this one now, which you may or may not want. But since we trimmed that off, now they're 2 separate objects and they have separate geometric constraints applied to them. So you got to be careful of trimming stuff sometimes. It allows it to change or move. Something else we can look at is the symmetry of this. We want this to be in the middle of the part, I believe. If we look here. Well, maybe not. Let's do a little math here. So trying to figure out if this should be in the middle or not. We know the total width is 85. So if you cut that in half, the center of this line should be at 42.5, which it's not because this is 35 plus another 10 would put it at 45. So it's not exactly in the middle. Okay, so maybe let's just throw a dimension on here at this point. We do know that this should be 35. And this is one of those instances where you say, well, where'd my sketch go? It just got really big so you can't see it. So you can do a zoom extents or zoom out. Here we go. So that's 35. We know this should be 20. There we go. And then we know our overall should be 85. So let's put our overall distance on here of 85. There we go. So once you get into parts that are a little more complicated, you're not going to be able to use the straightforward process of do all your geometric constraints and then do all your dimensions and you're done. You start to kind of dance back and forth between the two of let me do some geometric constraints. Okay, now I'm going to throw a dimension or 2 on here, then go back and do some more geometric constraints that you start to, as you get more experienced, bounce back and forth between these. But you want to remember always, these geometric constraints are always your weapon of choice if you can. Okay, so I got that in there. It's a little closer now. You can see we've broken some things again. So we had this circle locked onto our line right here really nicely, and now it's moving around again. So let's go back and grab that coincident constraint again and patch that up. So I want the center of this circle to be in line with this axis. and that locks that in. Okay, I can do the same thing to fix this. So you may not notice this, but if I drag these lines around on the top and bottom, they don't necessarily line up with the center of the circle. And we can look at the drawing and see that if I extended those, they would go right through the center point of the circle. So that's one of those lesser known examples of when you need to use the coincident constraint. So we're going to do a coincident between a line and a center point. So I'm going to say, after I grab my coincident constraint, this line needs to match up with the center of this circle, as does this one. So this needs to match up also with the center of that circle. That does two things. It makes sure that the line is in the correct place in relation to the circle, and it also makes that make sure the line is in correct location relative to the other line. Okay. So we're getting closer here now. We need to probably put some height information on this thing now. So let's put a total height on here, which is 100. So I'm going to go back to a dimension. Let's go from top to bottom and put 100. Also, in general, when you're using the dimension tool, try to pick entire lines. Stay away from dimensioning to endpoints. Dimensioning to endpoints doesn't always remove as many degrees of freedom as you want to. So dimensioning to endpoints is usually kind of a bad practice. You want to grab the entire line, okay? So you can see I do that. And what I mean by that is don't dimension from here to here, because what that does is it allows the line to change its angle if it wants to. Excuse me. So you want to dimension to the entire line if you can. So that should be 100. All right, so at this point, Inventor says 5 dimensions needed. We're getting to where this is getting a little complicated now, and it's hard to figure out what's left. So this is where you start to hit escape a couple times. Anything that's purple, drag it around. So we can see this is not really located. It stays in its basic shape, but it's shifting around in our 3D modeling environment. So we need to lock that down somehow. The best way to do that would probably just be with some kind of a constraint. And this is going to be kind of arbitrary, but let's say maybe, because this part's not really symmetric left to right, how do we want to do this? I want to show you guys a good way of doing this, but okay, let's do this. Let's learn the construction line tool, because this would be a good chance to use it. Let's draw some construction lines in, which are imaginary lines that we can use to constrain or build our part if we need to. Okay, so I want to make the center of this part really match up to the origin, but there's nothing in the center that I can choose. So here's what we're going to do. We're going to grab the line tool, and we're going to draw an imaginary line, or 2 of them. We're going to go up here and choose the construction line tool and turn that on. It's this red button. It works like an on-off switch. So it's on. If I hit it again, it turns off. Okay, I'm going to turn it on, and we're going to draw construction lines from corner to corner on this thing. So I'm going to go from this corner down to here, and then from this corner down to here. Okay, and when we do that, if I hit escape a couple times, what that does now is it gives me a point right here, or a location that becomes the center of our drawing. So now what I could do if I want this thing to be centered around the XYZ axis is I could say, well, let's make this point right here. If I use a coincident constraint, I want the crossing point between these 2 construction lines. If I choose that, I want that to match up to the origin of my model right here. And that's going to do a lot. You can see it turns a lot of our geometry from purple to black because it locates it. Okay. And again, these are imaginary, so they will not be visible in the finished object. They're just there to help constrain and build things. That's really what construction lines are for. All right, so at this point, we're down to the circles. So this thing's obviously going to need a size. So if we look at our drawing here, it's a radius of 21. So let's grab the dimension tool, click on the curve, put in 21. Remember, you can tell if it's doing a radius or a diameter based on the number of arrowheads. Since you have 1 arrowhead, that means it's a radius. Let's do this guy over here now. So these circles should both be a diameter of 12, and they should be 15 from the edges. So I'm going to do this one at the top. So this is a diameter of 12, and if I dimension to the center point, that should be 15, and if I dimension to here, that should be 15. And at that point, we're fully constrained because remember, we have symmetry top to bottom. So if I make the top symmetric with the bottom, this hole is now driven by that one. Okay. So at this point, I would recommend you go ahead and finish this sketch and extrude it, and I'll show you why. If I decide to fillet this thing now, if I grab my fillet tool and put in those fillets that are, where are they? 10, right here. They've got a radius of 10. There's a chance that this is going to break some of my sketch and unconstrain it when I have it done. So I'm going to put in 10 millimeters here, and if I start choosing things, a lot of times this can break your sketch. In this instance, we might be okay. I don't know. Am I happy or not happy? I think we're okay. It looks too narrow, but it says it's 85, which is the right dimension. And so I think in this instance, we're okay. I have forgotten an entire piece of the model here, so we probably should go back and do that. But in this instance, the fillet works okay. You can do it in the model section when you're done also if you want. All right, let's put this in. I totally left this part out. So let's draw a circle right here on this axis. And you can see this is trying to grab onto all kinds of stuff now with these inferred constraints because this model is getting pretty complicated. So I'm going to find somewhere where it's not locking onto anything and draw that. And then we need a couple of tangent lines coming off there. So I'm going to grab my line tool and just go to the top where it's yellow right here. Straight across, go to the bottom, straight across. I'm going to grab my trim tool and trim this circle out. And then we can go ahead and dimension this. We know it's going to have a radius of 10 and the center point is 25 from the edge. So let's dimension this. This curve is 10. And if I dimension from the center point to the edge, that's 25. Hit escape. And now you can see we've got something that's still purple here. So if I drag this around, what do I need there? So take a look through your geometric constraints for a minute and see if you can find the geometric constraint that would fix this, or one of them that would. There's a couple. Okay, so two ways you could do this. You could either use the symmetric constraint between the lines, like this top line and the bottom one, or you could use the tangent constraint, which I think is easier in this case. So I'm going to pick tangent. 2 clicks, we're fixed. Okay. Now, lastly, I'm going to trim this out right here, and that's probably going to break some things. So let's see what happens. There we go. This is one of the tricks of parametric sketching. We had this done, right? I went and trimmed one line, and it went from this back to this, and it's like, oh, I'm starting all over again. Are you serious? I just had this done. It's not usually as bad as you think. So hit escape a couple times and drag it around. Now, before we even do that, if you look, when I trim this, watch for dimensions that disappear. If I do Control Z and Control Y. So the thing that blows this apart is the lines that were dimensioned were trimmed away so they don't apply anymore. Okay. So if you look at this, see my overall dimension at the top that disappears. This one disappears. Some of our hole locations disappear. So I'm going to go ahead and put those overall dimensions back on. That should be 85 still. This should be 35 still. I know that this dimension disappeared for the hole. It should still be 15. This one should still be 25 like we had on there. Okay. So at this point I'm kind of stumped. It says 1 dimension needed. Let's hit escape and drag this thing around somewhere. Like maybe if I choose this line. Why is it not constrained? Okay, there we go. It's moving, right? And if you look, my construction lines are out of whack. So this one's not attached to the lines anymore. So what I'm going to do is try and reattach my construction lines to my actual object. And this is another reason why it may be better to not do these fillets, because if I hadn't done these fillets, this endpoint would stay locked on like it's supposed to. Okay. So if I was doing this again, I probably would not put these fillets on. I would model them. But at this point, here's how I can fix this. I can go with a coincident constraint and say I want the endpoint of this to be coincident with this line. and that's going to kick it back over. So what did that do? Let's go back. Okay. I can see that this line is not attached over here where it should be anymore. This end point really should sit where the corner of this part used to be, right there, right? But it's not, because when I trimmed this line out, it broke that constraint. This used to be one continuous line that went all the way through our part, and when I trimmed it off right here, it separated it into two separate pieces. And at that point, Inventor says, well, there used to be one line here and it had these constraints on it, and you broke it apart into two, so I'm just going to make those constraints disappear because I don't know what to do with them. So what happens is this line is no longer attached to that corner point like it used to be. So I can see that it's attached top to bottom. Like it matches up with this line still. If I go straight across, it's matched up this way. But left to right, it's not. So I really need this line right here to kick back over so that it's matched up with this point. So the best way to do that is to grab your coincident constraint, and we're going to say that this point needs to be coincident with this line. Boom, there we go. Everything's fixed. So let's go ahead and finish this thing now and extrude it. This one got a little nasty. I would say this is more of an intermediate level difficulty. So if this one frustrated you a little bit, that's kind of what it's supposed to do at this point. So don't feel bad if you kind of fought with this one for a while. It's not easy. Let's go extrude. Choose our different sections here, and they've really improved this feature recognition, I think, in Inventor in this release. It used to have problems with trying to choose closed profiles, and I think they fixed that, it looks like, or made it better at least. So our thickness is going to be 8 here, symmetric, and hit OK. That one's done. So let's call this figure P2-8. Let's do a save as. Save. That one's done. We can upload it. And now we're on to the very last one, which I think is really a little bit easier. So this one's called a distance plate. It's also millimeters. So let's do our last one here. We're really going to go a little quicker on this one. So new, millimeters, 2D sketch, XY plane, project your geometry. X and Y. On this one, I always like to look at the easiest way to do everything. I'm not going to sketch the fillets on this one. I'm going to model them at the end. So let's do a rectangle to start with. So I'm going to grab my rectangle, draw that in there. Let's make it symmetric. So I'm going to use symmetry and say it's symmetric top to bottom around the x-axis. Hit symmetry again. It's symmetric left to right around the y-axis. Grab my line tool, and I'm going to go in here on the inside and put these little cutouts that are going to appear like that. Let's go ahead and trim this off and mirror these 3 lines to the other side with this as my mirror line. Then grab trim and trim off this side. Okay, there we go. So we're getting kind of the basic shape put in here. Now, we do see that this is symmetric top to bottom and left to right. So I need to check this thing for symmetry. So if I hit escape a couple times, I can see it's not symmetric right now. If I move this, the bottom doesn't move. So let's go symmetry, top to bottom with this axis. Hit escape. That looks good. That looks good. So we've got some good symmetry going here now. I do want this to match the bottom one also. So let's go symmetry one more time. And I'm going to say this line has to be symmetric to this one around the x-axis. Okay, it does not like that. Let's try these lines instead. If I make this symmetric to this one around this axis. Okay, it likes that. The other way you could do that is you could have used a collinear constraint or made this line equal to this one. So there's lots of ways to get around this stuff. So there's the basic shape of this thing. I've got it behaving nicely. So let's throw a couple of overall dimensions on here now. So it's supposed to be 50 that way and 50 this way. So if I dimension from here to here, that's 50. Let's zoom way out. Hit escape a couple times, drag this thing out where we can see it again. And what has this done? It's like crossed over itself somehow. Let's undo that. Let's dimension this one first. Oops, hang on. Start over. This should be off the center line. If I dimension from here to here, that should be 50. And this should be 50. There we go. Okay. Sometimes Inventor does better if you do dimensions one way or another. The other way you could do this that it would like it a lot better probably is if you put overall dimensions. Inventor usually likes overall dimensions better. So if I put 100 in there and then dimension from here to here and make that 100, Inventor probably will like that better. Still not exactly sure what this thing is doing, why it's adding lines in, but whatever. Okay, so that's our basic shape for this thing. So 100 by 100. If we look, these are inset 20 millimeters. And the total height of these gaps is 40. So we know this distance should be 20. This distance should be 40. There we go. So we're getting the basic size in there now. And then lastly, we need to put the little cutout in the middle and then the holes around the corners, and we can fill with this. So another little trick you can use, like for this guy here, we know this is going to be right in the center, and its size, its overall size is going to be 20 by 20. So I'm going to drop this down and use a special type of rectangle tool called the 2-point center rectangle. And what that lets you do is you can choose a center point instead of a corner point. So I'm going to pick the center point right here and draw out this rectangle. And you can see it constrains it based on its center point, almost like a circle. There are times where using this one can be very frustrating, but for this it works great. So don't fall in love with it. It's not always the answer. But for certain times, if you want to lock a rectangle on based on its center point, it works really well. So this is 20. And I know it's going to be square, so I'm just going to hit the equals constraint and make the top and side equal. So there's that guy, and then we just need to get the corners here with the circles. So these are all 12, and they are 35 from the center. So let's draw one in here. Let's go off this top left corner maybe. Watch out for all these inferred constraints. So I'm going to go maybe right here. I'm going to dimension that to be 12. Now I'm going to dimension it off the center. So from here to here, 35, and from here to here, 35. Now we can just mirror it. So let's grab the mirror tool, choose that circle. My mirror line is going to be the vertical axis. Hit apply. Now I can stay in that mirror tool, choose both circles, choose my horizontal mirror line, and hit apply, and we're done. So at that point, I'm going to hit finish sketch. Let's go ahead and extrude it, and then we'll put the fillets on. So we extrude this guy. This thing is 16 millimeters. Choose your profiles. Let's go symmetric, 16 millimeters. Hit OK. And now you just got to grab the fillet tool and be careful about which edges you're picking. But we're going to do a bunch of fillets that are 10. There's 8 of them total. So let's go fillet. Radius of 10. We're going to choose these two corners on each section. And hit OK. At that point, we can save it. This is 2-10. Hit save, and we are done. So you can upload that one. So that's a quick run through, or kind of quick, I guess, on doing these 3 lab activities. It's not the only way you can do them, but it is one way you can do them. So again, make sure your sketches are fully constrained, that they are all totally black. You don't want to see any purple lines or circles. And make sure you're using geometric constraints first and dimensions when needed. Remember, the geometric constraints are always more powerful, more robust. They create better design intent. They're a better way of controlling the shape of your part. Use dimensions to control size and location when needed, but the overall shape and relationship between your part and the way things react and change should be done with geometric constraints. So hopefully watching me do these and kind of walking through them with me helps you kind of cement some of this stuff in your brain and figure out, kind of how to do this and get a little bit of practice. So at this point, hopefully you're getting a little bit of comfort with the sketching environment in Inventor, but it does help to do more and more and more of these. The best way to get good at this is to practice. So that's all I got for you guys in this lab video. Good luck, and I'll see you in session 5. Bye.